Hello, so today we are going to do this problem, which is a part of Leetcode daily challenge, pass the pillow. So basically with this problem, we have n people standing in line from 1 to n. So pretty straightforward. You can imagine you have the first one, second one, all the way until n, right? And they are passing a pillow between each other. So every second, one person passes the pillow to the next one. So now the pillow is here, they passes it to the next one, all the way until this one passes it here. And then once they reach the end of the line, they start passing it backwards, right, in the other direction. So that's pretty much what's described here. Now what we get as input are two numbers, n, which is the number of people in the line, so from 1 to n, and then the time in seconds. So, for example, at time 1, we would be here, the pillow would be here. At time 2, the pillow would be here, because every second the pillow is passed from one person to the other, right? And so the goal of the problem is to return which person has the pillow at a certain time, right? And which person, we just denote that by just the index of where they are standing in the line, right? So for example here, for the first example, n equal to 4 and the time is 5. So first second, 1 passes it to 2. After that, 2 passes it to 3, 3 to 4. Okay, so how many seconds? 1 second, 2 seconds, 3 seconds at this point. And then 4 passes it to 3 because we changed direction, and 3 passes it to 2. So here this is time 4, and then when 3 passes it to 2, we are at time 5. So that's the exact time we are looking for, and so we return 2. Okay, so pretty straightforward. Now if you look at the constraint, they are very small, 1000 for both n and time. So that tells you we could just do pretty much just a simulation of what is happening, right? We could just do exactly what was done here. Let's do that first. What would that look like? Well, that would basically be, we want to know which person has the pillow, so let's just call that current at a certain point in time. We definitely need that. So first, the first one, and since the line starts at 1, we just, the person at 1 has the pillow. And now, as long as there is still time, we will keep going, and every time we'll subtract 1, because we want to know at time. So we could either have another variable t and just make sure t is less than or equal to time and then increment t, or the same, a different way of doing it is just decrementing until we reach 0, right? Now, there are a couple of things we need to do. The direction changes. So first we go from 1 to 2, 2 to 3 to 4, and then we go back. So when we are going forward, we just are incrementing the index of the person that has the pillow, right? So first 1 plus 1, 2 plus 1, 3 plus 1, 4. And then when we need to change the direction, we do minus 1, okay? So when do we do minus 1? We do minus 1 when we reach, we start decrementing when we reach n, which is 4, right? But then also, let's say this continued, right? Let's say t was longer and it continued. Maybe we have 3 to 2 to 1. Now we need to start going forward again, right? So the value that we add, so in this section here, all the way to 4, each time we do current plus 1. But after this, until here, we do current minus 1. Okay, but then when we start here, we start doing plus 1 again, right? So basically this, the plus that we are doing, this is the same as doing plus minus 1, right? So this value just needs to change when we switch direction. So let's call that value d. Initially it's 1 because initially we increment by just 1. And every time we keep doing current plus d. But when do we change direction? So if we reach n, like here, we need to start switch the direction of the value we are adding each time. So if current is equal to n, we need to do just multiply by minus 1. And this will take care of also switching the sign back to plus, because -1 multiplied by -1 is +1. But we also remember, when we reach 1, we also want to start incrementing, which means changing the direction. So either that or when it starts equal to 1. Okay? Now, when time is equal to 0, we could just return the current, because that's the person that has the pillow at that moment. So if I run this, looks good, let's submit, it gets accepted. Now, in terms of time complexity, this is O of time, because each time we decrement by 1 on each iteration. So overall, this runs O of time. So it's O of time and O of 1 space. But can we do better than O of time? Well, we can actually do a constant space, constant time solution. How? So the first thing to think about is, let's take maybe let's take this, right? Let's see what's happening here in this sequence. So we have 1, we go 2, let's say maybe n here is equal to 5, right? What happens for n equal to 5? We go 4, 5, 6, and then we change direction. So now 5, 4, 3, 2, 1, 2, 3, 4, 5, and then we change direction. So 4, 3, 2, 1. So what happens? So we go all the way to 4. Then when we reach n, we switch back. And then when we reach 1, we go forward. And then we go all the way to 5, 3, 2, and then we keep going. Okay? Now you might think about, okay, why this slightly weird division here? Like, why not do 5 like this? Well, if we do 5, then still it's a little bit weird, because this one starts at 4, right? So it's easier to just do it like this. Now, why? Because this way we can actually shorten our calculation and do take a shortcut. Because let's say if time is 100, it's a waste to do all the operations, because we know we need to do at least 10 of these 5 rounds. So if we do 10 of these 10 rounds, by rounds I mean just one of these. If we do 10 rounds multiplied, each one of them is 5, each one of them is 4, because each one has 4. Then that's 40 already, okay? But let's say we do even 20, right? That's 80, right? Now if we do, just increase that, maybe we do 5, that's 100. And we already know that we need 5 rounds, but we do not need more. So we are actually at the first position. Now let's say the time is maybe 2. Then we know we definitely need 100 round, and then for the other round we start from 1 and just go to 2, right? So we know the position that it's at the second person, at the third person. Actually, that's what okay? So how do we do that in a math term, right? This one, it happens that we were going in this direction, right? But what if it was 100, maybe this is 4, maybe 6, for example, okay? Then we know it fits somewhere here in the other direction. And so it's actually, so this one goes 1, 2, 3, and then 4, and then 5, and then 6. So it should be at 3, okay? But how do we calculate this? Well, we know each round is going to need only n-1. You can see it here. We have 4 for each round. And then we have to change direction. And so each round is basically n-1. n-1 passes, right? That's what it, okay? Because we pass from 1 to 2 to 3 to 4. And so to determine the number of rounds, we can just take time divided by n-1. Okay? Now to know in which position we are at the last round, which basically the last round is the round that didn't complete, so we stop it either here or here. how do we do that? Well, that's usually something that we do with modulo, right? But the problem is we don't know if we are going in a forward direction or a backward direction. How do we know? So this would be like the position. How do we know whether we are in the forward or backward direction? Well, you can see it here. So this first round, let's call it round 0. This one round 1, this one round 2, this one round 3. Now what did you notice? For the rounds where we are going backwards, it's always, the number of the round is always going to be odd. And for the rounds where we are going forward, it's going to be even, right? So to know if we are going forward, we just need to check the rounds index. If it's even, that means we are going forward. Otherwise, it means we are going backwards. Now, what changes for the direction? Now, if we are going forward, then we can just return this, right? But if we are going backwards, then let's call this the remainder maybe. Then we can just return the remainder. But if we are going backwards, that doesn't really work, right? Because the index is for the index from 1 to n, right? Should tell us the index in the line 1 to n. And so if we are in the backward direction, the position for 4 is actually just n minus the remainder, because you just need to subtract n minus so that you get the position in the other direction, right? So this is just going to be n minus 0, like this, okay? So that's pretty much the reasoning here, and you can see this is an O of 1 calculation. So let's just do that like this. So rounds is going to be equal to this, the remainder is this, and then we check the rounds, and here this can be just returned like this, and that should be it. So if I run this, looks like there is a slight thing here. So this is because we start numbering from 1. We need, I think, to do +1 here. Yes, so we need to do +1 just because we start numbering from 1, and this gets accepted. And this solution is of 1 time, so it's a lot faster than the previous one. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one.